Lesson 2.1 is the trigonometry of non-right triangles. So in section 1.5 and 1.6, we talked about SOHCAHTOA and right triangles. This is for what happens when none of your angles is a right angle. One way that we do these is by the sine rule, or the law of sines, which is used for non-right triangles of the form angle, angle, side, or angle, side, side. So remember back from your congruent triangles, if you have an angle, angle, side triangle, that means you know two angles in a row and then the following side. Angle, angle, side. If you have an angle, side, angle triangle, you know two angles and the side in between them, the included side. Or angle, angle, side, angle, side, side is an angle and then the following two sides. And it can go in either order as long as it's circular. For those of you who have taken pre-calc or enhanced 3 before, we studied angle, side, side, and we called it the ambiguous case, which there was a lot to it. That is not something that comes up on the IB exam, so you don't have to worry about the 0, 1, or 2 triangles that sometimes comes up with an angle, side, side triangle. So if you have a triangle where you have angles A, B, and C, we use capital letters for the angles. And then you have sides, lowercase a, lowercase b, and lowercase c. The way you always label a triangle is opposite side across from opposite angle. So if this is angle A, then this is going to be side A. Angle B, side B, angle C, side C. So then there's a ratio between the side lengths and the sine of the angles. So side A over sine A is equal to side B over sine of angle B, which is equal to side C over sine of angle C. Or you could flip it over, either way. But the side over the corresponding sine of the angle. So for this first example, it says in triangle QRS, side QR is 15 meters, side SR is 6.5 meters, and angle S is 125 degrees. So we have an angle, side, side triangle, which means we can use law of sines, or the sine rule, and we want to find angle Q. So because it's angle, side, side, I can use the law of sines, or the sine rule, and so I just set it up in general here. I'd have Q, side Q, over sine of angle Q is equal to side R over sine of angle R, which is equal to side S over sine of angle S. So then if we plug in what we know side Q is this side SR, so that's 6.5, and then we don't know angle Q. We don't know side R or angle R. And then side S is this side QR, which is 15, and angle S is 125 degrees. So now you have these ratios here, and you have one of them is only missing one piece of information, and one of them is complete. So you can use these two ratios to solve for the angle Q. So go ahead and pause the video and solve for angle Q. So we set up our law of sines here, and so I took the one that with the sine of Q, the angle Q that I want to solve for, and I set it equal to the one that was complete. And then I cross multiplied. So I had 6.5 times the sine of 125 degrees equals 15 times the sine of Q. And I divided both sides by 15, so the sine of Q is equal to 6.5 sine of 125 degrees over 15. And then I wanted to find Q, which means I need to switch into inverse trig. So Q is the sine inverse of 6.5 sine 125 degrees over 15. Plugged this in my calculator, and I ended up with 20.8 degrees. So this next example, a ship S is on a bearing of 120 degrees from port A, so this angle here from north is 120 degrees, and 42 degrees from port B. The distance between ports A and ports B is 15.2 meters, and we want to find the distance from the ship to each of the two ports. So go ahead and pause the video and try this one. So the first thing I did was I found my angles inside my triangle. So this is a straight line, which means the angle has to add up to 180 degrees. So if this exterior angle is 120 degrees, then the interior angle must be 60 degrees. And then I used the fact that all three angles in a triangle have to add up to 180 degrees to find that my missing angle is 78 degrees. So now I have an angle, side, angle triangle, which means I can use law of sines. So I set up my law of sines. We don't know side A, which is this side BS here, but angle A is 60 degrees, so A over sine of 60 degrees is equal to B, which is the distance between port A and the ship, over sine of 42 degrees, which is equal to this distance 15.2 meters over the sine of 78 degrees. So if you haven't already done so, go ahead and pause the video and find the two distances. So I took my two ratios where I didn't know the side and set them equal to the ratio that I knew everything. So I took A over sine 60 degrees set equal to 15.2 over sine of 78 degrees. And then I just multiplied both sides by sine of 60 degrees and plugged that in my calculator, and I got that the distance from port B to the ship is 13.5 meters. And then I did the same thing for the other piece of the ratio. I set B over sine 42 degrees equal to 15.2 over sine of 78 degrees, multiplied both sides by the sine of 42 degrees, and got side B, which is the distance from port A to the ship, to be 10.4 meters. This next example says a Park Service plans to build a bridge AC over a reservoir. Points A and B are 2 points on the short side of the reservoir, where distance AB is 14 meters. Angle A is 102 degrees, and angle B, which is inside the triangle, is 58 degrees. So given this information, calculate the length of the bridge AC to the nearest meter. So we have an angle side angle triangle, so we can use the law of sines. So I set up the law of sines here. A is over sine of angle A is equal to side B over sine of angle B, which is equal to side C over sine of angle C. And then the first thing I did was I found my missing angle C, knowing that all three angles in a triangle have to add up to 180 degrees. So I did 180 degrees minus the angles 102 and 58 degrees, and got that this angle C was 20 degrees. So then I set up my ratios with my known information plugged in. So side A over sine of 102 degrees is equal to side B over sine of 58 degrees, which is equal to 14 over sine of 20 degrees. And then based on my picture, I want side B over here because that's side AC. So I took this side B over sine 58 degrees is equal to 14 over sine of 20 degrees. I multiplied both sides by the sine of 58 degrees, plugged that in my calculator, and got to the nearest meter, this bridge should be 35 meters. For this next example, two people are sitting at points A and B observing a sailboat at point C. The distance between the two observers is 20 meters. The angle of the observation for angle A is 65 degrees. The angle for angle B is 42 degrees. And we want to find the distance from the ship to the shoreline. So we want to find this distance here, the distance from the ship to the shoreline, which whenever you do a distance from a point to a line, you always make it a perpendicular line. So go ahead and pause the video and see if you can find this distance. So we have an angle side angle triangle. So again, I set up the law of sines. I found our missing angle C by the fact that all three angles have to add up to 180 degrees. So this angle C is 73 degrees. And I plugged in my missing information into my law of sines. And then using that, you don't have to find both of these, but you need to find one of your two missing sides. So if you found this side A over here, you would do A over sine of 65 degrees is equal to 20 over sine 73 degrees, multiply both sides by sine of 65 degrees, you would get 18.95437. If you did side B, you would do B over sine of 42 degrees is equal to 20 over sine of 73 degrees, multiply both sides by the sine of 42, and you end up with 13.994087. So now you have, depending on which side you found, you have a right triangle. So you can use that right triangle to help you find this height. So if you haven't already done so, go ahead and pause the video and find the distance from the sailboat to the shoreline. So depending on which hypotenuse you found, you're going to set up SOHCAHTOA, and you are looking for the opposite, and you have the hypotenuse, so that's sine. So if you found this distance A, you would set up that the sine of 42 degrees is equal to h, your opposite, over 18.95437, and then multiply both sides by that, and you would end up with 12.7 meters. Or if you found side B over here, you would do the same thing. Sine of 65 degrees is equal to h over 13.994087. Multiply both sides by the denominator, and again, you would end up with 12.7 meters. So you use law of sines to find a missing side for your hypotenuse, and then you have a right triangle, and you can use SOHCAHTOA. So the other two types of triangles that we haven't talked about yet are your side angle side triangles, where you know two sides and the included angle, or the angle in between, and side 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 triangles, which means you know all three sides but no angles. So those are the cosine rule, or the law of cosines. So what the cosine rule says is that a squared is equal to b squared plus c squared minus 2bc cosine a. You could also rewrite this depending on what information you knew or you needed. So you could have used this for b, so side b squared is equal to side a squared plus side c squared minus 2ac cosine of angle b, or c squared is equal to a squared plus b squared minus 2ab cosine of angle c. So a couple things to notice: whatever side is on the outside is the angle that is in the inside cosine. So they kind of sandwich, and then everything else is together on the inside. So A, and then B and C in the middle. B and B, A and C in the middle, C and C, A and B in the middle. If you wanted to, you could solve this for the cosine part here if you needed to solve for angles. So for example, if I took this first one and I solve for cosine, it would be cosine of A is equal to side B squared plus C squared minus A squared all over 2BC. And it doesn't matter how you label it, as long as, again, the angle that's inside cosine matches the side that's by itself on the other side of the equal sign. So for this first example, it says find all the angles of triangle ABC, given that side A is 14 meters, side B is 12 meters, and side C is 7 meters. So I drew a little picture here, and we have a side triangle. So because this is side triangle, we are going to have to use the law of cosines, or the cosine rule, which says a squared is equal to b squared plus c squared minus 2bc cosine A. And it doesn't matter which angle you start with. I'm just going to start with angle A first. So I just plugged in the information that I know into cosine. So side A is 14, side B is 12, side C is 7, again B and C, and then I'm solving for angle A. So then I solve this thing for cosine, and you end up with cosine of A is equal to 12 squared plus 7 squared minus 14 squared all over 2 times 12 times 7. So then I just plugged this first part in my calculator and got -3, and then this bottom part I got 168. So cosine of A is equal to -3 over 168. So if I want to find angle A, then I need to take the cosine of that. I need to switch into inverse trig form. So I have A is equal to cosine inverse of -3 over 168, or 91.0 degrees. So go ahead and pause the video and do the same thing for angle B. So I did the same thing. I set up my law of cosines with B. So I have 12 squared is equal to 14 squared plus 7 squared minus 2 times 14 times 7 cosine of angle B. I solved this thing for cosine of B, that's equal to 14 squared plus 7 squared minus 12 squared all over 2 times 14 times 7, or 101 over 196. So then to find angle B, I need to use inverse trig. So B is equal to the cosine inverse of 101 over 196. Plug that in my calculator, I got 59.0 degrees. So if you haven't already done so, go ahead and pause the video and find angle C. So I just used the fact that all three angles in the triangle have to add up to 180 degrees. So I did 180 degrees minus 91.0 degrees minus 59.0 degrees, and got that angle C is 30.0 degrees. So number 2, it says find the length of Lake CB, given that the distances AB is 290 meters, the distance AC is 225 meters, and angle A is 72 degrees. So go ahead and pause the video and find distance CB. So we have a side angle side triangle, which means we can use the law of cosines, and I called this side A over here because this was angle A. So A squared is equal to B squared plus C squared minus 2BC cosine A, where B was 225 meters and C was 290 meters, and angle A was 72 degrees. Plugged all that in my calculator and got A to be 307 meters. So for this last example, towns A, B, and C form triangle ABC with sides BC to be 8 kilometers and side AC to be 13 kilometers and angle C to be 50 degrees. And we want to find the 2 missing angles. So go ahead and pause the video and try that. So before you can find either of the angles, you have to find the missing side. Otherwise, if you try and plug it into law of cosines, you'd have a missing piece of information. So I know I can use law of cosines because it's a side angle side triangle. And I have side C squared, that's the side that I'm missing, is equal to side A, which would be 8 squared, plus side B, which would be 13 squared, minus 2 times 8 times 13, times the cosine of C, which is 50 degrees. I plugged that in my calculator, took the square root, and got side C to be 9.964947425 meters. Now we have all 3 sides. Now you can find your missing angles. So go ahead and pause the video and find your 2 angles. So I set up the law of cosines again, and I just chose to find angle A first. So I said A squared, which was 8 squared, is equal to B, which is 13 squared, plus c, we just found 9.96 squared minus 2 times 13 times 9.96 times the cosine of angle A. So I solved that thing for the cosine of angle A, and I simplified, and I got 204 over 259. So I took the cosine inverse in order to find angle A of 204 over 259 and got 38.0 degrees. Even though I wrote 204, 259, and 9.96, I didn't actually use the rounded answers. I used the answer button or the unrounded answers from my graphing calculator. So just be careful on that. Try not to prematurely round. Don't round until your very last step. And then I just used the fact that all three angles in a triangle have to add up to 180 degrees. So angle B would be 180 degrees minus angle A of 38.0 degrees and angle C of 50 degrees. So you end up with angle B to be 92.0 degrees. So this has been solving non-right triangles using the law of sines for angle, angle, side, angle, side, angle, and angle, side, side triangles, and the law of cosines for side, 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 and side, angle, side triangles.